Hello friends, I hope you are doing well. I come back with another video here, a practical application of a shift register that used to track a bottle or any faulty bottles. As you see on the screen, there is a conveyor and also filling and the capping machine and a bottle detector and the cup detector. So this one will reject any uncrowned bottles. Okay, so when we fill a bottle, the filling machine fills and the counter also couples. So this cup detector will detect uncrowned or a bottle without a crown. So when it reaches to the pusher or rejector, the rejector will reject that uncrowned bottle. Let's feed some bottles. Here my bottle sensor. Let me feed one bottle first. As you see, one bottle is fitted, and let's feed more. Let me feed more bottle. Let me feed. I think the both are enough. In practically, this shift button will be related with the encoder. So shifting will be done by the encoder, not by shift. So by shift button in practical. So let's run the conveyor, or let me start shifting. As you see, the bolts are moving, and at the cup detector, let's say this bottle has not crown, so this one is that. Okay, let's shift. Let again, this bottle is again not capped. Run the conveyor. So also let's this bottle is again not capped, so let's detect that one. So let's run the conveyor. When the uncrowned bottle reaches to the rejector will be reject that bottle. You see, it rejects the uncrowned bottle, as you see. So let's, as you see, it's rejecting. Let's say this bottle had not crowned again. So let's run. The rejector is rejecting again. Good. This is how the faulty bottles are rejected. So again, it's active. This rejector is active. It's rejected. So likewise, we can detect uncrowned bottles and reject that from our product line. So it works like this. Uh, this is one interesting practical application of a shift register for tracking bottles. So this is let's do the program on thematic manager. I have already created my project. So let's open OB1. I'm going to create the program on OB1. Okay, let's say the first one is to detect the feeded bottles. Say here we can put the set trigger, and we can also put the clock pulse positive. Okay, this is going to be my bottle detector or bottle present detector, and so I am going to use memory double 100. So let's parameterize that one from the last bit. I'm going to use the right shift register. So I have explained this thing many times how we are going to use. Okay, let's insert again network. My second network is going to be the cup detector. So the same. Okay, we can put set here. We can put positive trigger. Okay, this is going to be my cup detector sensor. I connected to the input 2.0, and this is going to be the 106.5. This is the actual position of the sensor. Actual position of the. Let me show one time. The cup detector is here. So when it reaches, the shift register will reach at this one. This means 106.5. This one. Let's say this one. I have to add one. Okay, I will back to this. So when I say memory 106.5 means this is the actual position of the cup detector sensor. Okay. So let's now start the insert the let's insert one network for the shifting. This is shift register. Okay. This is actually I have to insert one, but in practical this must be the encoder pulse M1.0. But currently I integrated this one with the HMI shift register button. This one I integrated with this one, and let's put here a positive trigger again. And let's add the shift right. I'm going to use shift right register, shift right double, this one. Okay, and my shift register for the bottles is MD 100. This is a shift register for the filled bottles, or the shift register for all bottles. Let's copy again, and let's put this one MD 100 for this shift register is for what, for uncapped, or and let's use this one MD 108 for the rejector. This is for all bottles, and this one is for the uncrown, and this is for the rejection system. I'm almost done. Let's add one network again. Let's write program for the rejector, reject uncrowned uncrowned bottles, bottles. So this is going to be X word end for the logic system, word end double. Okay, so I am going to compare my good bottle with the with the uncrowned register, shift register. So I have to compare. Then this I will move this to the MD 108. If both the for the bottle register and the uncrowned register are one, that means the faulty bottle has detected. Okay, then let's compare. Sorry again, comparator, double comparator. If MD 18 reached at word 1620. Again, this one hexa 20 means the actual position of the rejector. That means around here, here. So this is actual position for the rejector. That's why I'm comparing again with the MD 8, MD 108. So if that bottle, if the defective bottle reaches to the position at 20 hexa, so the rejector will be active here. If the bottle that reaches, the defective bottle reaches here, this rejector will reject. So let's blow out that bottle again here. Let's give off timer off delay timer. Okay, let's say this one is timer 1, and S5 time. Let's say, wow, you can make it 1 second, but it's for fast. Yeah, we have to make 30 milliseconds. Okay, and this is the output. Our rejector or the rejection valve is connected. So let me say one time again for this network. So when we compare MD 100 means all filled bottles. MD 100 MD 100 is for all bottles, and MD 104 is for uncrowned bottle. If the uncrowned bottle is detected, so there will be a register on this shift register. So when we compare, that means we end bitwise ending these two. If both the value is 1, it means we got a defective. It reaches as 20 hexa. It will uh, reject, activate this one for 300 milliseconds. So it will reject. Okay, this one, I think it is clear. Okay, for our program, I'm done. For simulation purposes, after the rejection, we can put one network, simulate bottle after rejector. Okay, I'm done. So the program looks like this one. Let me explain one time. Network one is to detect all bottles that are fed to the machine. Network two is for detecting uncrowned bottles or bottles that doesn't have a crown. Network three is for shift registers. All shift registers. My first shift register is for all bottles, and the second is for the uncrowned the bottles, and the third is for the rejection, for the rejector. Okay, The fourth network is to reject the bottle that doesn't have a crown. So it will blow out the bottles to the garbage bin. The fifth network is not practically not usable but I put here for simulating bottle for simulation purpose after the rejection system. Okay, let's load our program again. Let's test this. So let's start loading. This button is not necessary for practical because those buttons are shifted by the encoders. Or when the conveyor runs, this encoder will send pulses to the PLC, so these pulses will be used to shift the shift registers. So let's feed bottle. Let me feed more bottle. Let's feed more bottle. So the machine is filling now, and the filling and cupping. So when it reaches on the cup detectors, it detects uncrowned. Let's say this one is the detectors, the address for the detector. So let's activate. Also the shift register for the this one is also active. Let's shift again. Let's shift and let's more. Let's again the shift the cup detector detects uncrowned again. Shift now. We got two bottles that doesn't have a cup. So let's shift. Let's run the conveyor. You see, it's rejecting. You see, rejecting. I'm done on today's video. Thank you again watching for my videos. See you on my next topic again.